Here in example 4, it says given a function and one of its zeros, find the rest of the zeros. So what we've got is I as a root. That's why there's a comma there. So we're going to go ahead and set up a synthetic division and put I on the outside. And then we put our coefficients for the polynomial on the top row. And then we bring down the first term and then multiply by I. When you add the column, you have 2 plus I. And then we're going to multiply 2 plus I times the I on the outside. So that's going to be I times 2 is 2I. And then you have I times I, which is going to be I squared, and I squared is negative 1. So negative 1 and 2I. When you add those, the 1's cancel, so you just get 2I. And then I times 2I is 2I squared, but the I squared makes it negative 2, and we get remainder 0. So we knew we were going to get remainder 0 because they told me I. We also know that conjugate theorem, that if I goes in, so does the conjugate. So negative I should go in. We bring down the 1, multiply, we get negative I. Add the column, the i's cancel, you get 2. 2 times negative I is negative 2I, and then that makes remainder 0. And then we're left with a 2, which is a constant, and a 1x. And so we just set that x plus 2 equal to 0, and we get negative 2 as our last answer. So we have three answers. We have a real negative 2, an imaginary I, and an imaginary negative I for the zeros of that function. For B, they're giving us negative 5I. So we're going to put that outside the L. And then we've got 1, 3, 25, and 75 for our coefficients. We bring down the 1, multiply by negative 5I. When you add the column, you get 3 minus 5I. Then you multiply, you're going to get negative 15I. And then you're going to get positive 25I squared, which is going to make negative 25. Then you add the column together. The 25s are going to cancel out. So you're just going to get negative 15I. And then after your negative 15I, you multiply that by negative 5I, which is going to give you positive 75I squared. And the I squared will make the positive 75 negative, and then that gives you remainder 0. And then we know if negative 5I goes in, so will positive 5I. So we bring down the 1, multiply by 5I, and then when you add the column, the 5i's cancel and you get 3. Then you have 3 times 5i, which is going to be positive 15i. And then when you add them, you get remainder 0. And so now we're left with x plus 3. We set that equal to 0, and we're going to get negative 3 as our real answer, and then we've got 5i and negative 5i as our two imaginary answers. For C, we've got I on the outside as the root, and we've got 1 for the x to the fourth. There are 0 x cubes. There's a 26x squared, a 0x, and a 25. So we have to put zeros where the missing terms would be. We bring down the first number, multiply by I, add the column, you get I, multiply I times I is I squared, which is negative 1, add the column, which would be 25, multiply by I, you get 25I, add the column, you get 25I, multiply by I, and you get 25I squared. The I squared makes a negative 1, so it would be negative 25. And you add that column and you get 0, which is the remainder. So if I goes in, so does its conjugate, negative I. We take that out next. Bring down the 1, multiply, add your column, multiply, add your column, multiply, and we're going to get negative 25i, which gives you remainder 0. And so what we're left with here is 25 is our constant, 0 is our x, and 1 would be x squared. So we're left with x squared plus 25. We set that equal to 0. Subtract 25 to the other side, take the square root, and then we end up getting plus or minus 5i, because it is a negative under the square root. So we have 4 imaginary answers. We've got I, negative I, 5i, and negative 5i. So all 4 answers are imaginary. For D, it's a little more complex because you've got 5 minus I as the root. So we've got 5 minus I, and then I've got 1, negative 12, 46, and negative 52 as my coefficients. And we bring down the first term. You multiply 1 times 5 minus I, which is 5 minus I. You add your column, and you're going to get negative 7 for the real numbers, and then minus I for the imaginary. Now, when you multiply this times the outside, you're going to have to FOIL. So we're going to have, let's do it off to the side over here. So I'm going to have 5 minus I and negative 7 minus I. So that's going to make negative 35, a positive 7i, a negative 5i, and a positive I squared, which makes negative 1. That's negative 1. So the real numbers are a negative 36, and then the i's go together to make a positive 2i. So that is what's going into the next spot, negative 36 plus 2i. So when we add this column, we've got 46 minus 36, which is 10, and then we've got the plus 2i. Then we multiply these together, and I'm going to be lazy. I could multiply them again, but I already know that this is going to give me remainder 0. So when I multiply these, I know I'm going to get 52. So I'm just being lazy, knowing that it's going to be remainder 0. But if you're unsure of yourself, you really should multiply them together and make sure that you get 52 and make sure that you've done it right up to that point. So we know that if 5 minus I goes in, so will 5 plus I. So that's the next one to come out. 1 comes down, we multiply, you add your column together, and the i's cancel, you just get negative 2. Then you multiply by negative 2, and you're going to get negative 10 and negative 2i, which makes remainder 0. And then your leftovers, we're left with a constant and a 1x, so we set that equal to 0, and we get 2. So 2 is your real number, and then we've got 2 imaginary zeros as well, 5 plus I and 5 minus I. And then our last one is very similar to that. So we've got 1 plus I on the outside. And then we've got 5, negative 7, 4, and 6 for our coefficients. You bring down your first number, multiply by the outside, and you get 5 plus 5i. Add your column, you get negative 2 plus 5i. And then we need to multiply first times the outside times this, and you get a foiling problem. So we've got I plus, or 1 plus I, and negative 2 plus 5i, which makes negative 2, negative 2i, and this will make 5i and 5i squared. The 5i squared really is going to be negative 5. So the numbers, the real numbers, are going to make negative 7. And then the i's are going to make positive 3i. And that goes in this spot under the 4. Negative 7 plus 3i. Then we add our column together and we get negative 3 plus 3i. And then we multiply again, and you should FOIL these, but I'm going to be lazy again. I know it's going to be negative 6 because they told me it was going to be a root, and roots have remainder 0. I've got 1 plus I, which means its conjugate should also come out. So we now do synthetic with the conjugate. So bring down the 5, multiply by 5, you get 5 minus 5i. The i's cancel, and the 5 minus 2 gives you 3. And then 3 times this will be 3. 3 times negative I is negative 3i. We get that remainder 0 that we need. And so we're left with a 3 as a constant and a 5 as the x. So we take that leftover number equation and set it equal to 0. So we're going to subtract 3 and divide by the 5, which gives me negative 3/5. So I've got negative 3/5 is my real 0. Sorry. Negative 3/5 is my real 0, and then I also have what I took out before, the 1 plus I and the 1 minus I. 1 plus I, 1 minus I are my imaginary zeros.